thanks for clicking. Welcome to another Knowledge Math production. Today we're going to be talking about cross-multiplying fractions and comparing fractions against one another. How do I figure out if I'm given two fractions, which one is larger than the other? So to do that, we're going to use the technique that you learned a long time ago. We're going to learn how to do it with cross-multiplying two fractions. So hopefully you remember how to cross multiply. If you have two equal ratios or two equal fractions, A over B equals C over D, to cross multiply them, you multiply the numerator of the first fraction times the denominator in the second fraction. So we multiply A times D, and then put it up where A is, and then we'd multiply B times C and put that number up where C is. Okay? That's how we cross multiply. So, why do we do this? The reason we can cross multiply fractions is we want to compare them. Cross multiplying fractions tells us if two fractions are equal or which one is larger than the other. Okay, that's useful when you're working with larger fractions that you don't really know how to reduce and that are not easy necessarily, let's say, to find a common denominator, a number that's in common between them. So, for example, which of these two fractions is larger, 4 over 26 or 7 over 32? So when you look at these fractions, it's certainly not obvious if one is bigger than the other. Okay? It shouldn't be obvious. So what we can do is we can literally cross multiply. We're going to multiply the 4 times the 32. So 32 times 4. 2 times 4 is 8, and 3 times 4 is 12. That's 128. We're going to write it over here next to the 4. That's where it goes. And then 26 times 7, 42, 4 to carry, 14. So these two get multiplied, and it gives me 182. Okay? So now, which one is larger than the other? Well, the 182 is certainly bigger than 128, right? So that means 7 over 32 is larger than 4 over 26. Okay? That would be my answer. All right? The biggest thing you got to remember is you got to remember to write the number that you multiply in the right spot. So when you do 26 times 7, it goes over here with the 7 over 32 fraction. When you do the 32 times 4, 128 goes over here with the numerator of 4. All right? So that's how we can use cross multiplying to figure out if one fraction is larger than another. Okay, let's compare these fractions. All right, so now you can do this with a drawing, right? There's a few ways you can do it. You can also do it by taking 6 over 10 and reducing it. We'll multiply the two fractions first, and then we're going to go from there. So we're going to do 2 times 10, that's 20. And then 5 times 6, that's 30. 30 is greater than 20, so that means 6 over 10 is greater than 2/5. You could have shaded in the diagram to see that as well. You could also have put the 6 over 10 in lowest terms, divide them both by 2, because 2 goes into both. It gives you 3 over 5. Well, if you have 3 parts out of 5, that's certainly greater than 2 parts out of 5. Okay? So 2/5 is less than 3/5. And remember, this is the less than sign because you can write the word less in it. Don't forget that. All right? So that's a bunch of ways you could compare those fractions. Okay, now let's order these fractions from the smallest to the largest. All right, so now we could multiply all these a bunch of times if we want to, but to be honest, I don't think we have to. Okay? Let's say you had a circle or whatever it is. You took something like a circle and you divided it into, well, depending on how many pieces are here, you divided it into 3 pieces, 7 pieces, 5 pieces, 2 pieces, and 4 pieces. The question is, we have one piece every time. We only have one of the pieces that the circle's been divided into. So which of these 5 would be the smallest if we only have one of its pieces every time? Well, the smallest one is going to be the one that's divided into the most pieces, right? So think about it. If I had a circle that was divided into, let's say, 8 pieces, 7 pieces is hard to draw, and then I had a circle that was divided into 4 pieces, and I had only one of the 8 pieces, and then I had one of the 4 pieces, well, the one of the 4 pieces of the circle would definitely be bigger than one of the 8. So the smallest number here is the number that has the biggest denominator, 1/7, right? 1/7. That's the smallest of the bunch. The next smallest will be 1/5, because that's the next largest number of pieces, and I only have one. Then 1/4, then 1/3, and the largest number is 1/2. Because for 1/2, you're only breaking the circle up into 2 pieces, and you have one of those 2 big pieces. So that's going to be the largest of the bunch. Okay? So that's a way that you can do it. If the numerators are all the same, then you can work like that as if it were a diagram. Okay, now let's compare these fractions. All right, we can use equal or unequal. We can put fractions in lowest terms. We can also multiply them to compare them. Instead of using unequal, we're going to use greater than or less than, I think. All right, to figure out which is greater than or less than. That's always important. So 5/15 and 1/3. So we can multiply them. 3 times 5, that's 15. 1 times 15, that's 15. So these are equal. You also could have divided both of them by 5. That gives you 1/3. So yeah, they're equal. Okay, 7/3 versus 16/6. So I could divide 16/6 by 2. That would give me 8/3. So which is going to be larger, 7/3 or 8/3? So 7/3 is smaller than 8/3, right? Okay. So 2/18 versus 1/9. Well, I could divide both of these by 2. That would give me 1/9. So these are equal. Or I could also multiply. 2 times 9 is 18. 18 times 1 is 18. 4/6 versus 8/10. I can multiply these. 4 times 10 is 40. 6 times 8 is 48. So the 48 is bigger than the 40. So that means 4/6 is less than 8/10. I also could have divided each one of these by 2. That would give me 4/5. And that one by 2. That would give me 2/3. That may still not be obvious to you. So then you do 2 times 5, that's 10. 3 times 4, that's 12. This one is the larger one. Okay, 3/5 and 12/20. 3 times 20 is 60. 5 times 12 is 60. So these are equal. Right? 4 goes into each one of these. 4 goes into 12 3 times. 4 goes into 25. Yes, they are equal, 3/5. And then finally 9/4 and 27/15. So 3 goes into each one of these. That's 9/5. So 9/4 versus 9/5. If I divide my group into 4 pieces and I have 9, or 5 pieces and I have 9, when will I have more? Here. Again, you don't know that. 15 times 9. 9 times 5 is 45. 4 to carry. 135 over there. 27 times 4. 8. 2 to carry. 108 over there. So this one is the larger one. Okay? So there's lots of ways to compare them. All right. Finally, we're going to solve this equation. Okay, so you remember cross multiplying, hopefully. So cross multiply, set them equal, cross multiply. So we have 16 times x would be 16x. 9 times 27. 9 times 27. So 9 times 7 is 63. 6 to carry. 2 times 9 is 18. 18 and 6, 24. So that's equal to 243. So 243 has to equal 16x. Now, hopefully you remember to solve for x. It's 16 times x. You're going to have to divide both sides by 16. We're going to have to do some math here. 16 goes into 243. I don't know if it goes in even. We're going to find out. And I don't think so. 16 goes into 243 or 224 one time. 8 remaining. 16 goes into 83. It doesn't go in evenly. So since it doesn't go in evenly, I'm not going to write a whole number here. My answer is going to be this fraction, 243 over 16. Now the question is there any number that goes into 243 and 16? I don't think so. So I'm going to leave my answer at 243 over 16. Okay, and then finally, we're going to solve for the missing number. There's a few ways that you can do this. All right, there's a few ways that you can do this. You can multiply, make an equivalent fraction. You can cross multiply and solve. I'm going to show you a couple of them, okay? So 3 of them I'm going to do one way. The other 3 I'll do another way. So the first way I'm going to do it is by cross multiplying and solving. So let's see. We have 3 times 8. That's 24. 4 times x, let's say. 4x. Divide both sides by 4. We get 6. 2 times 33. 66. 11 times x. 11x. Divide both sides by 11. We get 6. And then 28 times x is 28x. 16 times 14. 6 times 4 is 24. 2 to carry. 6. 6 times 1 is 6. 1, 4, 2. 224. So divide both sides by 28. 224 over 28. What number goes in even? 6. Nope, not enough. 8 maybe? Yes, 8. 28 times 8. 8 times 8 is 64. 6 to carry. 2 times 8 is 16, and 6 more is 224. So it is 8. So that's 8. That's one way to do it. Cross multiply and solve it. Okay, the other way to do it is to make equivalent fractions. So for example, I want to know 5 over something is equal to 20 over 12. Well, if I do 5 times 4, I would get 20. Okay? Or let's do it this way. Rather than multiply. You could do it with multiply, and you could also do it with divide. I think it's a little easier here with this one to do divide. So 20 divided by 4 would be 5. So 12 divided by 4 would be 3. This is 5 over 3. Over here, 5 times 5 is 25. So something times 5 will be 35. What's the something? 7. Or do 35 divided by 5. It's 7. 6 times 4 is 24. So something times 4 is 36. What times 4 is 36? 9. Or 36 divided by 4 is 9. Okay? So there's a bunch of ways to do these. Okay? All of them are okay. All right? As long as you do your math correct, that's all that counts. And that's it. And as always, thanks for clicking.